Right, so can I focus your attention on this side of the board then? Right? Did anybody have a go at this? So I've asked, can you find the area between these 4 points? Y equals x squared plus 4, which I've drawn here. It's just a parabola, which has just been moved up by 4 units. Okay. The x-axis, which of course is this axis down here. And the two lines, x equals -2, which is this line here. I've only just drawn a portion of it. And x equals 3, which is this portion of the line over here. Okay. So in other words, what I'm asking you to do is, can you find the area which I've shaded? Can you find the area which I've shaded? Does anybody have any ideas? How could you do this? Now, Denise, you're smiling at me. Is this because you've seen this stuff before?
I don't remember it.
Okay, you don't remember this. That's fine. Okay. So this is now moving on to a topic called integration.
Really?
Yep. Has anybody heard of integration before, the topic in maths? Yeah. Okay, good. So this stuff on this side is to do with differentiation. Okay, and if you remember when I first introduced this, I said that this is under a big topic called calculus. Differentiation and integration kind of go together under that topic. Okay, they're literally reverses of each other. But I'm first of all going to introduce it from a completely separate point of view. All that stuff on that side of the board was to do with finding gradients. So differentiation is to do with finding gradients. Okay, we're happy with that, right? This stuff over here, integration, is to do with finding areas. Okay, it's to do with finding areas. So differentiation is to do with gradients. Integration is to do with areas. So if you didn't know about integration, and if I just literally gave you this problem, how could you do it?
Yeah, I know how to do basic integration.
Okay, so don't worry about integration now. Imagine you didn't know anything about integration. I appreciate some of you have looked at this before. If you didn't know anything about integration, how would you answer this problem? If I just said, find the area under this curve, how would you do it?
Maybe divide it down.
What do you mean divide it down?
You can get two rectangles.
Perfect, okay? So what we could literally do is divide this area up into shapes which we do know how to work out the area of, namely rectangles, okay? All right, so why don't we do this then? Why don't we create a rectangle from -2 to -1, okay, and work out the area of that rectangle, okay? In fact, let's do that. Let's do that, okay? So let's work out the area of this rectangle here, okay? Let's work out the area of this rectangle here. How would I do that?
We need to get where the curve is intersected with the line, so we need to put -2 in the equation.
Perfect. So in other words, you've got the base, it's just 1, but you also need a height to work out the area. Okay, does that make sense?
Yeah.
Yeah? So if I'm going to work out an approximation for the area, okay, rectangle 1 is just going to be 1, because it's between -2 and -1, that's the base, times by the height. So what would the height of this rectangle be from here to here?
I think it would be 4 plus 8.
4 plus,
4 plus 4 is 8.
which is 8. Yeah, good. So it would be 1 times 8. You all happy with where we got that 8 from? What we're literally doing is sticking -2 into this curve here, because we're after what is the height from there to there. Okay? So in other words, we need to know what the height of this is. In other words, where does it hit the y-axis? Make sense? So just stick -2 into here. We get -2 squared, which is 4. Add the 4, that gives us our 8. Okay? So then we just do the same thing for the next rectangle. So let's go from -1, move that one across. Okay, so move that one across. So work out the area of the next rectangle, this one here. Okay, so plus, what's the height of this rectangle going to be?
5.
It's going to be 5. You happy with that? Yeah? And then we keep going. Okay, so then we work out the area of the next rectangle. Well, I guess if we want a good approximation, why don't we go for that height? Okay, it's that height. So in other words, we work out the height from 1 instead. Yeah? From 1, okay. So what's it going to be? It's going to be 1 multiplied by, going to be 5 again. Okay. And then we keep going. So let's go from 2. So we go, there's from 2, work our way across, work out the height of that rectangle. What do we get? So it's going to be 1 times by 8. And then we do the last one. Okay, then we do the last one. So work out the area of that rectangle there. Okay, so it's going to be 1 multiplied by 13. Okay, does that make sense what we've done there? Megan, does this make sense? Okay, all I asked you to do is work out the area which I had shaded in red at the start. So all I'm doing is just breaking it up into rectangles. Breaking it up into rectangles. And then the height of the rectangle is just going to be where this point hits the curve. Yeah? So okay then, what does this equal?
39.
39. So what I'm saying, just to recap, I've broken this area up into rectangles. Now, of course, it's not going to be exact. It's not going to be exact. You can see that, like there's bits which I'm massively over by. In fact, is this approximation going to be more or less than the actual value?
More.
It's going to be more because look at all this. Look at all this area which I didn't want. Okay? So all I've done is I've just broken it up into rectangles, and I've basically said the height of the rectangle is just going to be where the point hits the curve. Okay? In other words, I just need to stick the x value into this curve and I'll find the height of the rectangle. Does that make sense? Does that make sense to everyone? Okay?